When dealing with submerged turbine pump sumps above underground gasoline tanks, it is essential to prioritize safety and adhere to electrical codes. The use of compression fittings in such locations is generally not recommended, as they are typically not listed for this specific application. This is primarily due to the potential fire or explosion hazard that could arise from using unlisted fittings in a hazardous environment. Instead, several alternative solutions can be considered to ensure a safe and code-compliant installation. Firstly, consider using a flexible conduit with explosion-proof fittings. This approach offers a practical way to adjust the conduit length and location without compromising safety. Flexible conduit allows for movement and adjustments, which can be beneficial when aligning with the pump head. Ensure that the flexible conduit and its fittings are specifically listed for use in Class 1 Division 1 hazardous locations. These fittings are designed to contain any internal explosion and prevent the propagation of flames to the surrounding atmosphere. Secondly, another viable option involves installing a conduit body with compression connectors approved for hazardous locations, specifically Class 1 Division 1. A conduit body provides a robust connection point and facilitates changes in direction within the conduit run. When selecting a conduit body, verify that it is clearly marked for use in hazardous locations and that it meets the required standards for explosion-proof performance. The compression connectors used with the conduit body must also be similarly listed and approved. If feasible, a third option is to raise the pump to a suitable level where the conduit can be threaded without difficulty. Raising the pump might eliminate the need for compression fittings or other potentially hazardous solutions by allowing for a direct, threaded connection to the conduit system. This can simplify the installation and enhance the overall safety of the system. If raising the pump is considered, ensure that doing so does not introduce other safety or operational concerns. For example, verify that the pump remains adequately submerged for proper cooling and performance. Regardless of the chosen solution, certain additional considerations are paramount. Sealing is a critical aspect of any conduit installation in a hazardous location. Ensure that all conduit connections, including those at the pump, conduit bodies, and any other fittings, are properly sealed to prevent the entry of gasoline fumes or other hazardous materials. Use sealing fittings and compounds specifically designed for hazardous locations and follow the manufacturer's instructions carefully. Proper grounding is another essential element of a safe and code-compliant installation. Follow all applicable electrical codes and standards for grounding the conduit system. This typically involves using a grounding conductor within the conduit and bonding the conduit to the equipment grounding system. Grounding helps to minimize the risk of electrical shock and provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse. Remember, safety should always be the top priority when working in hazardous locations. Engage qualified electricians who are experienced in working with hazardous locations and ensure that all established safety protocols are followed. This includes wearing appropriate personal protective equipment, using calibrated testing equipment, and adhering to lockout-tagout procedures when working on electrical circuits. Installing the conduit system in accordance with electrical codes such as the National Electrical Code ensures compliance and minimizes potential risks. The NEC provides specific requirements for electrical installations in hazardous locations, including the type of wiring methods permitted, sealing requirements, and grounding requirements. Familiarize yourself with the relevant sections of the NEC and follow them meticulously. There are several benefits of avoiding compression fittings in this type of application. Compression fittings are not listed for use in submerged turbine pump sumps above underground gasoline tanks because their use can pose a fire or explosion hazard. The design and construction of compression fittings may not provide the same level of protection against the ingress of flammable vapors as explosion-proof fittings. In contrast, explosion-proof fittings and properly threaded conduits provide a more reliable and durable connection. These fittings are designed to withstand internal explosions and prevent the escape of flames, thereby mitigating the risk of fire or explosion. Consider the specific requirements outlined in the National Electrical Code, or NEC, which is a comprehensive set of standards for electrical installations. Article 500.1 defines hazardous locations as those areas where fire or explosion hazards may exist due to flammable gases, vapors, liquids, combustible dust, or ignitable fibers or flyings. Article 514 addresses the specific requirements for gasoline dispensing and service stations, including the classification of hazardous locations around fuel dispensing equipment. Section 514. 8 covers the wiring methods permitted in hazardous locations at gasoline dispensing facilities. It specifies that wiring in Class 1 Division 1 and 2 locations must comply with Article 501, which outlines the requirements for explosion-proof wiring methods. Section 501.10 permits the use of rigid metal conduit, rigid non-metallic conduit, or electrical metallic tubing, or EMT, with threaded fittings in Class 1 Division 1 locations. It also allows for the use of explosion-proof flexible metal conduit or explosion-proof liquid-type flexible metal conduit with approved fittings. Section 501.15 addresses sealing requirements for conduits passing from hazardous to non-hazardous locations or between different hazardous locations. It mandates the use of explosion-proof sealing fittings to prevent the propagation of flames or vapors through the conduit system. Section 501.16 covers grounding requirements for equipment in hazardous locations. It emphasizes the importance of bonding all metal parts of the electrical system to ensure a low impedance ground path. Section 514.16 specifically addresses grounding requirements for gasoline dispensing equipment. It requires that all metal parts of the dispensing equipment, including the conduit system, be bonded together and grounded to a common grounding electrode system. Section 514.11 provides requirements for circuit disconnecting means, ensuring that electrical circuits can be safely de-energized for maintenance or repair. Section 514.13 addresses the requirements for equipment located in or on dispensing devices, specifying that such equipment must be approved for use in Class 1 Division 1 locations. When installing conduit in a hazardous location, there are several important steps to follow. Firstly, classify the area according to the NEC to determine the appropriate wiring methods and equipment. Secondly, select conduit and fittings that are specifically listed and approved for use in the classified hazardous location. Thirdly, install the conduit system in accordance with the NEC and the manufacturer's instructions. Fourthly, ensure that all conduit connections are properly tightened and sealed to prevent the entry of flammable vapors or liquids. Fifthly, ground the conduit system in accordance with the NEC and bond all metal parts to a common grounding electrode system. Sixthly, inspect the completed installation to verify that it meets all applicable requirements. When selecting flexible conduit for use in hazardous locations, ensure that it is specifically listed for such applications. Explosion-proof flexible metal conduit or explosion-proof liquid-type flexible metal conduit are acceptable options. When using flexible conduit, pay close attention to the minimum bending radius specified by the manufacturer. Exceeding the minimum bending radius can damage the conduit and compromise its explosion-proof integrity. When installing conduit bodies in hazardous locations, select those that are specifically marked for use in Class 1 Division 1 locations. Ensure that the conduit body is properly sized for the conduit run and that it is installed in accordance with the manufacturer's instructions. When using compression connectors with conduit bodies in hazardous locations, verify that the connectors are listed for use in such applications. Follow the manufacturer's instructions carefully when installing compression connectors to ensure a proper and secure connection. Proper sealing is essential to prevent the migration of flammable vapors or liquids through the conduit system. Use sealing fittings specifically designed for hazardous locations and follow the manufacturer's instructions for installation. When installing sealing fittings, ensure that the sealing compound is properly mixed and applied to create a vapor-tight seal. After the sealing compound has cured, inspect the seal to verify that it is free of cracks or voids. Grounding is a critical safety measure that helps to minimize the risk of electrical shock and fire. Ensure that the conduit system is properly grounded in accordance with the NEC. Use grounding bushings or bonding jumpers to connect the conduit to the equipment grounding system. Verify that the grounding electrode system is properly installed and maintained. Regular inspections and maintenance are essential to ensure the continued safety and reliability of the electrical system in hazardous locations. Conduct periodic inspections to identify any signs of damage, corrosion, or deterioration. Repair any defects promptly to prevent potential hazards. Follow a preventive maintenance schedule to ensure that all components of the electrical system are functioning properly. Keep accurate records of all inspections, maintenance, and repairs. When working in hazardous locations, always prioritize safety. Wear appropriate personal protective equipment, such as safety glasses, gloves, and flame-resistant clothing. Use calibrated testing equipment to verify that the electrical system is energized before performing any work. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of the potential hazards in the work area, such as flammable vapors or liquids. Work in a well-ventilated area to minimize the risk of exposure to hazardous substances. If you are not qualified to work in hazardous locations, seek assistance from a qualified electrician. The information provided here is intended for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified engineer or electrician to ensure that your electrical installation meets all applicable codes and standards. Improper electrical installations in hazardous locations can have serious consequences, including fire, explosion, injury, or death. By following the recommendations outlined here and adhering to all applicable codes and standards, you can help to ensure a safe and code-compliant installation. Remember to always prioritize safety and engage qualified professionals when working with electrical systems in hazardous locations. This approach minimizes risks and ensures a reliable electrical system.